Today we shall discuss regarding probability. In ninth standard we have learned something regarding probability and the basic concepts too. And in 10th standard we shall learn some more concepts regarding probability and some more problems which we have not seen in ninth standard. First of all, the word probability means the chance of happening an event, and we have to learn regarding experiment. An experiment is an operation which can produce some well-defined outcomes. There are different types of experiments. Mainly two main types of experiments we have. First one is random experiment and second one is deterministic experiment. Random experiment means an experiment which, when performed, produces one of these several possible outcomes is called random experiment. In other words, random experiment is an experiment whose all possible outcomes are known in advance and no particular outcome can be predicted in advance. And examples for random experiments are throwing a die, tossing a coin, spinning the number wheel, etc. And deterministic experiments are that kind of experiments which we perform in science laboratories, and the experiments whose outcome can be predicted in advance when it is repeated under similar conditions is called a deterministic experiment. Deterministic experiment is an experiment whose outcome can be predicted in advance when it is repeated under similar conditions. In our NCERT syllabus, deterministic experiment is not included. Only we have problems based on random experiments. And we have learned something regarding experimental or empirical probabilities in 9th standard. Similarly, theoretical or classical probability. We have learned the definitions in 9th standard. And we shall see what is a trial. A trial means performing a random experiment is nothing but a trial. Performing a random experiment is nothing but a trial. Next one is an event. Before discussing regarding event, we shall discuss regarding the sample space of a random experiment. The sample space of a random experiment is a set of collection of all possible outcomes of a random experiment. And if we collect some of these outcomes or all of these outcomes which are kept in a sample space, then it is called as an event. An event is a subset of sample space. Subset means it is a set, or else it is a group having an event from the sample space, or else a group of events from the sample space. Next one, compound events. An event which is having more than one possible outcome is called a compound event. Elementary event. An event which is having only one outcome is called an elementary event. One thing we have, the sum of probabilities of all the elementary events of an experiment is 1. Next one is equally likely events. If the probabilities of 2 or more events are same, then they are called as equally likely events. If the probabilities of 2 or more events of a random experiment are same, it is called as equally likely events. For example, when we throw a die, the probability of getting the number 3 on the top face is 1 by 6, and the probability of getting number 5 on the top face is 1 by 6. Like this, whatever the events we have whose probability is 1 by 6 will be called as equally likely events. And next one, sure event and impossible event. Sure event means an event whose probability is 1 is called as sure event, and an event whose probability is 0 is called impossible event. Here we shall see the problems based on these definitions. Let us see the problems based on probability. First one, in a class of 12 students, 5 are boys and the rest are girls. Find the probability that a student selected will be a girl. Here, in this problem, total number of students equal to 12, number of boys equal to 5, number of girls will be 12 minus 5, which is 7. So, probability that a selected student will be a girl is 7 by 12, which is number of outcomes favorable to the condition by total number of outcomes. Here total number of students is 12 and number of girls is 7. So 7 by 12 we can write. And second one, a die is thrown once. What is the probability of getting number 5 or 6? Before doing this problem, we should know one formula, that is probability of an event A or an event B is equal to probability of an event A plus probability of B minus probability of event A and B. Probability of getting this event 5 and 6 is 0 here. No die will be having the face with both the numbers 5 and 6, so it is 0. So by using this formula, we can write probability of 5 or 6 is equal to probability of 5 plus probability of 6. So which is equal to 1 by 6 plus 1 by 6, which is 2 by 6. Answer is 1 by 3. Third one, find the probability of getting 9, 7 and 6 on throwing 2 dice. Find the probability of getting the sum. It should be mentioned like this, but it is not printed in the book. So the sum of numbers on the 2 dice is 9. The probable, whenever 2 dice are thrown, the probable outcomes, the possible outcomes will be like this: 1 1, 1 2, 1 3, 1 4, like this, as we have seen in 9th standard. Even all possible outcomes are like this, which are 36 in number. So sum of numbers on the 2 dice is 9. The favorable outcomes will be like this: 3 6, 4 5, 5 4, 6 3. Total 4 outcomes will be like this. So probability of getting the sum 9 is equal to 4 by 36. 4 by 36 means 1 by 9 we can write. And probability of getting the sum equal to 7 is when we see the possible outcomes, whenever 2 dice are thrown, the outcomes which are favorable to our condition, sum is 7, is outcomes are 1 and 6, 2 and 5, 3 and 4, 4 and 3, 5 and 2, 6 and 1. Total 6 in number. So 6 by 36 we can take. 6 by 36 means 1 by 6. And the probability of getting sum 6, 1 and 5, 2 and 4, 3 and 3, 4 and 2, 5 and 1. Total 5 in number. So 5 by 36 we can take. Similarly, fourth one, a die is thrown once. Find the probability of getting an even number, a number greater than 3, a number between 3 and 6. Even number is even numbers when we throw a die are 2, 4, 6. So 3 in number, 3 by 6, that is 1 by 2. Number greater than 3, 4, 5, 6. 3 in number, 3 by 6, that is 1 by 2. Number between 3 and 6, that is 4 and 5, 2 by 6. So 1 by 3 we can get. Two numbers we have in this case. And next one, a die is thrown once, find the probability of getting an odd number. You can do this, a number greater than 4 and 7. Please try this problem, children. Find the probability of throwing a number greater than 5 with the ordinary die. Faces are numbered from 1 to 6. Greater than 5 with an ordinary die. Faces are numbered from 1 to 6. What is the answer, children? I can do it. It is an easier level problem. Only one number we have, that is 6. So 1 by 6 we can write here. A bag contains 7 red and 8 black balls. Find the probability of drawing a red ball. It is also so much easy. Total number of balls are 7 plus 8, which is 15. Probability of getting red ball is equal to, try this problem. In a cricket match, 8th one, Pakistan India team has to choose a captain out of the following players. With Pakistan, India team has to choose a captain. So Sehwag, Dravid, Sachin, Sourav Ganguly, Anil Kumble. What is the probability that Sourav Ganguly will be selected as a captain of the team? The probability that Sourav Ganguly will be selected is 1 by 5, as total number of players here mentioned are 5 in number, so we can take 1 by 5. And Sourav Ganguly or David, already I told you one formula, that is probability of A or B is equal to probability of A plus probability of B minus probability of A and B. The probability of selecting both the players as captain is 0, because in Indian cricket team only one captain can be there. For the captain position, only one candidate, one player will be selected. So it is 0. So we can take probability of A or B equal to probability of A plus probability of B for this case. So probability of Sourav Ganguly or Dravid is equal to probability of Sourav plus probability of Dravid. That is 1 by 5 plus 1 by 5, 2 by 5. And not Sachin. Non-Sachin players are 4 in number here. 4 by 5 we can take for the third one. And ninth problem we shall see in a beauty contest. Interesting. The following girls participated: Lara Datta, Priyanka Chopra, Dia Mirza, Selina Zetli, Aishwarya Rai, Sushmita Sen. Dear children, do this problem by your own. The question is like this: what is the probability that Lara Datta will be selected Miss Universe, as we have done in problem number 8? The same procedure we have to do for these questions in question number 9 too. Children, please try this problem. A box contains 40 balls of the same shape and weight. Among the balls, 10 balls are white, 16 are red, and rest are black. What is the probability that a ball drawn from the box is not black? Children, all these are easier problems. Please try to do this problem. Eleventh one is also an easier level problem. One formula you have to keep in note, that is probability of A or B is equal to probability of A plus probability of B minus probability of A and B. So many problems can be done in this section by whatever knowledge we have, which we gained from 9th class probability practice and within this 10th too. So I hope you all can do the problems from question number 11 to 20. And within these questions there are some card problems. Let us go through that. Question number 18, if you see a card is drawn from a pack of 52 cards, what is the probability of getting an ace? How many aces are there in a set of 52 cards? We have 4 ace cards, so probability of getting an ace is equal to 4 by 52, which is 1 by 13. My dear children, please go through the cards which can be there in a set of 52 cards so that you can understand. Number of ace cards is 4, so 4 by 52 we can write as the answer, 1 by 13. When a card is drawn from a pack of 52 cards, find the probability that it may be either a king or queen. Number of kings is 4, number of queens is 4. So children, probability of A or B equal to probability of A plus probability of B minus probability of A and B. This formula you can apply. Probability of king or queen is equal to probability of king plus probability of queen minus probability of king and queen. So there is no probability of a card having both king and queen, so it will be 0. So we can take the formula like probability of king or queen equal to probability of king plus probability of queen for question number 19 I'm speaking of. Please try to do this problem, children. Try this. A card is drawn from a pack of cards and a gambler bets that it is a spade or an ace. What are the odds against his winning this bet? Card is drawn from a well-shuffled pack of cards and a gambler says that it is a spade or an ace. Same formula, probability of A or B is equal to probability of A plus probability of B minus probability of A and B. Probability of spade is equal to number of spades will be 13. 13 by 52, that is 1 by 4. Number of aces is equal to 4. 4 by 52. 1 by 13. So both we have to add for getting probability of spade or an ace. So try this problem, children. One card is drawn from a pack of 52 cards. Find the probability that the card drawn is red or king. Children, try these problems. You go through the playing card sets and try to solve this problem. Question number 29. What is the chance that a non-leap year should have 53 Sundays? In a non-leap year, we have 52 weeks plus 1 day. So 52 Sundays already there. The probability of a non-leap year having 53 Sundays will be like this, that one extra day should be a Sunday. Then we can have 52 plus 1, 53 Sundays. That one extra day can be Sunday in one way. One by the probability of that extra day can become a Sunday is 1 by 7 here. So the probability that a non-leap year should have non-leap year having 53 Sundays is 1 by 7. This leap year problems and non-leap year problems you have to practice, children. And probability of having two students the same birthday and the probability of having two students different birthdays, this kind of problems are very important for board examination point of view. Children, do practice of these problems. Once again, you revise the concepts of 9th standard and try to solve the problems of 9th standard from reference books, which will be helpful for solving this problems of 10th standard too. I hope all the best. Thank you.